In this video, we will find out if you can build a real airplane that you can fly in that's made 100% out of cardboard. And we're also going to figure out what happens when you get cardboard wet.
We were supposed to fly tomorrow.
Where did this water come from? No. Cardboard airplane. Where do we start? Well, like all good projects, research is a necessity. Luckily for me, I have over 1,000 hours of XP building all sorts of airplanes, from big model airplanes to airplanes I can fly in. That allows me to do one important step here. Skip the airplane shape design, because I already have it on my head with how I want to do it. Basically what this means is how big is the airplane going to be, what's the shape going to be like, how big's the tail. It doesn't matter. I already have all that in my head. I already know how to do that. So we're going to go do the next thing. And we're going to go from the research box to the materials. We've worked with cardboard before, and I made this crappy cardboard boat.
Oh no. Oh, there's water in there. Oh no.
Honestly, that's not a lot of cardboard XP, so I'm going to need to get some more cardboard XP. So we need to test orientation on these structures. Do the flutes matter? So we are testing the flutes first. This one has vertical flutes. This one has sideways flutes. And this one is a combination. 1 cup of sand. Now I made a few of these small test ribs to test orientation for cardboard to see what's going to actually be more resilient to breaking. And this is what I found out.
There it is. Mixing them really does make a difference. It really is a waste of time to do it this way, it seems like. So no vertical flutes will be used in the wing spar at all.
Now that we've tested the spars, we've got the mixed flutes, the vertical flutes, the horizontal flutes, the mixed cap strips, we've got the data. You know what the data says? Build the actual spar. But now we know which way to build the spar. It's cardboard, but guess what? It's kind of sturdy. Wow, I could actually knock a small kid out with this thing. This is actually heavy. Oh no, this is not a great sign. So now we can build some wings. With the help of my handy dandy laser tool, we will now be cutting out ribs. Now, here's the interesting thing. Cardboard, if you use too much of it, is very, very heavy. So to make sure this structure is light enough to fly, I have to haul out most of the design. That means making this structure kind of open and strong. To do this, I'm boxing up the cardboard and reinforcing it in specific areas and then gluing it all together, making sure it has enough surface area to make good contact while still not using too much of the material itself. Am I really gonna fly in this? With the ribs complete, let's put some skin on the wing. Now, I'm not going to completely cover this in cardboard because I think that's going to be just a little bit too heavy. Now that we have wings, destructive testing. Alright, where were we? Alright, 42.2, let's go on the wing. 46.2. What are we up to? 110, 120, 130, 140. Where am I? 140? Oh. So the wing test went really, really good. That looks nice and solid. This is honestly my really big hang with this project because I knew if I couldn't get past this stage, we would not have a safe, flyable airplane. Because it's so heavy, I have to cover it in something. So, the brown paper packing that you can find to cover and protect your floors. That you can even do the finger test, where you poke it. Oh, and your finger's not supposed to go through it. But, you know, it takes a little bit of pressure. Like, that's pretty good. Until it's not. To put that into context, normal airplane covering is very, very tough. This is the Oratex wing from the 3rd ultralight. Like, I can take my fist and, like really hit it. And it doesn't do anything. That cardboard, it just like and it goes right through. So this is definitely unsafe, but I'm gonna fly it anyways, because I think it's safe enough. I mean, what is cardboard? It's basically just paper with the wavy thing in the center to form cardboard. This is gonna be a pretty solid wing, I would say. Just some cardboard garbage, it's turned out pretty sweet. It seems so legit. Like, to build an airplane out of cardboard, or not legit, but like legitimately stupid? Is it stupid? I don't know. It's just interesting. Like, to think I made this out of just complete trash material. we can move on from that because we have valid wings. This is where I'm going to try to sit. And now because I can skip the airframe design, because I already have it in my head, we can go on to the fuselage build. We're basically building an oversized RC airplane, much like the wings. So to do this, I'm going to actually just draw this generic looking RC airplane fuselage. We're going to cut these pieces out, and then we're going to glue them together. It's going to be very uncomfortable. I would be able to step in because the bottom should be strong enough. Squat down. Slide in. Yeah, I could probably fly this. Alright, down. Yeah, she fits perfectly in this thing. It's gonna be so funny when this thing's flying through the air.
I feel like Snoopy.
So now it's time to do something about this floor, because obviously this isn't really going to fly. So we got the bottom like this, and I want to put a top skin on it, probably 2 layers. But in the middle, I'm actually going to build cardboard, like slats, like this corrugated sort of thing. Build is going pretty good, I must say. It's pretty light. It's 17 pounds. Not too bad. 17 pounds of cardboard and hot glue. I'll take it. So we are using a little bit of wood. As long as I don't break that 95% rule of what the airplane's made out of, I don't really care. So we're gluing all this stuff in, and then it'll make more sense once we get on the airplane. This gets hidden in here. While those frames dry, it is now time to assemble our actual joint, wing joiner, wing box. I don't know what you call this, doohickey. This is the folded over cardboard that a couple of people mentioned. It's really strong, and yes, it is very strong. The problem is it's just hard to make it accurate because the folds themselves don't exactly line up every time you want to make a crease. Maybe it's a skill issue, I don't know. So we have plywood on the outside because obviously I need to have a plywood surface made to our plywood surface because we're going to use bolts to hold the wings on. That one goes there, this one goes there, right on the center line. Does this inspire confidence? Well, it probably doesn't, because right now there's no way this is going to work. So we're taking these doublers, and we're going to put these in here. It's a bit of a challenge to figure out how I want to actually mount the wings to a cardboard airplane while keeping the structure mostly cardboard. So we have to have a little bit of wood. If we were building this thing at the field and I could take this thing literally outside and go fly it, I could probably just make it out of cardboard and duct tape and not have to do any plywood. But with transporting in mind and taking it places, well, I think we have to use a little bit of wood just to make it a lot easier. So what I'm going to try to balance the airplane forward is about right here. Just based upon all my model building, it should probably balance out. You know, sometimes it doesn't really make so much sense to go crazy with the glue on certain things, because this glue is very strong, but it's only strong as the thing it's bonded to. It's bonded to cardboard. This is actually just more just to make sure it just doesn't go anywhere as far as like moving. As far as the lifting forces, you know, we're gonna have to deal with that some other way. Fuselage build looks good. Let's build the tail. Check it out. We have a pristine pizza box. No, this is actually our horizontal stabilizer for the airplane. So this looks pretty good. I'm actually really happy with this. For just the doubled up layers and using the skin as the structural number as far as resisting twisting. This looks great. So that's done. Now let's go check out the other surfaces that we've also made. It's really stiff. This was really solid. I think this is gonna work great. Now we have an elevator. In the second corner we have the other stabilizer. This is responsible for controlling yaw on the airplane and also stopping it from entering a spin. So you definitely make sure this is size big enough and cardboard enough. Well, let's hinge this one too. If you come over here, we have a freshly glued up rudder. So there we have it. These parts are lightweight and really strong. I'm happy with the cardboard for this. It's not coming off. This looks so good. I'm very happy with the way this stabilizer has turned out. It looks legit. It's very much legit tail section for an ultralight. Oh, there's something ridiculous about this whole project. Alright, I guess I'll start gluing this in overnight, and we'll have to add more reinforcements because I really need to make sure this doesn't rip off. We're actually going to put some flying wires on this, so up here I'm going to put a hard point in here on the front and back, and we're going to tie that to strings to the edge of the stabilizer and tie that into the bottom of the fuselage, so it's basically like a big triangulated truss. So that'll really prevent this from getting ripped out. So this is more than sturdy enough. Plus this is nice and strong. That's not going anywhere. So that is actually really impressive. Stiff. Man, this thing is super light. As far as the flying weight, we're just about there with the fuselage. I'd say 35 pounds of airplane. We've got 40 pounds of wing. This whole entire thing weighs 70 pounds right now. That's a real ultralight. And we just gotta put the motors on and that's it. I see that I'm using a piece of aluminum. However, it is not currently being used in this airplane for a manner that is conducive to flight. This is gonna be the king post. What the king post does is it holds the wings of the airplane up when it's sitting on the ground. When this airplane begins to take off and the tension gets put into the struts versus this thing, this you can actually completely remove. So some of you may complain and say that this is cheating. In my defense, this isn't really used for lifting the airplane or has anything to do with the actual flying qualities of the airplane, so therefore we can use this. So this fiberglass tape tension is extremely strong. So I'm just going to wrap this around. We're going to go around all the mounts. And there it is, 2 times over on each side. I mean, it looks god awful, but you know, it's back up. It's better than riding around just purely on the cardboard and Gorilla Glue holding it together, which I'm pretty sure it will hold it together, but just in case I'm wrong and it breaks, it'll end up transferring all that into this big tape sling. Time to get in the airplane. It's so small. Put the battery right here. Okay. All right, let's go up. I don't know if anything looks funny. So, I mean, that's all the weight. It's not even, it's definitely carried by the cardboard right now. Like, turbulence. Yeah. I have successfully crafted something that is actually probably more heavy than the cardboard airplane itself. So this is our jettisonable landing gear. So we have this, my feet, I just move one of my feet here for a brief second and push. And the carriage drops away like that. And now we have our fancy airframe, made out of nothing but just cardboard. However, if you guys are working on something fancier than cardboard, PCBWay can make your dreams a reality because they do so much more than just PCBs. For example, this is a past project. These are the aluminum blocks for my boat. These are CNC machined out of a solid block of aluminum. It's as simple as uploading your design to the website, submitting your request, got an instant quote, and then a few days later, boom, your part shows up. Speaking of boats, I know you guys talked about a large 3D printed boat. And this is a really, really big one. It's a giant lobster boat that I've submitted. It's currently on its way to my door right now. It's one of the largest 3D prints I have, and it's so big it won't even fit on my machines, but PCBWay's got the hookup because they got the big machines to make it happen. So if you guys are looking for making your own projects a reality, such as CNC machining, 3D printing, injection molding, sheet metal fabrication, and more, PCBWay is definitely the way to go. Check out PCBWay's Christmas sale to get up to 50% off their products until the 31st of December at the link down below. Check out PCBWay today. And if you're one of the first 40 to use discount code PCBWay-PeterSheeple10, you can get $10 off or it's over $30. You might be wondering, what is with this sled thing? Well, dear viewer, if you haven't been following me for a very long time, we actually did one of those man-flying drone things. But you should go check it out. I put my dad in it first, we flew it around via RC, had a DJI flight controller, then I got it and flew it around. But back on topic, it has motors. The lift in this thing is pretty good. Like each of these is about 30 something pounds, 30, 60, 90, 120, 120 pounds of thrust. Now we are going to lose some of it. It's not really 120 pounds because we're using them in like a pull push configuration, where this one's actually doing a little bit less work since they're the exact same blade pitch and size. This does a little bit less work. I think 120 pounds is more than enough for us to fly this piece of crap cardboard airplane. So I'm going to take this motor bar, we're going to slap it on that, and that will be our engine assembly. Put the 2 batteries into series, and that series connection goes into parallel, and then they make this noise. Whoa, shit. Something blew up. What did I screw up? I did screw the polarity! Ah, you idiot! Ah! Alright, that was like 45 minutes later of stupidity and resoldering. That's correct. That's correct. Here we go. It's in all the way. Alright, that's complete. Now here's the kicker. This airplane is very, very tight and narrow. It's not very big, and I really didn't design this that well. Yeah, let's crap out. So I get in the airplane, and it's such a tight fit. Maybe we should have done more airframe design as far as my accessibility inside of it. So I have to do some consultation because right now I'm at a roadblock. How do I get out of this thing easier if I have to get around the stick or if something gets mangled up? I also have to plug this to go to the side of the airplane and do all of that. Do we do manual controls? Like with my other airplanes, they have like cables and linkages that connect me to the flight surfaces. After doing all these pros and cons of manual control, having manual cables, having no electronic points of failure, and being cheap, the cons are it's complicated to route. It needs a solid structure to mount cables to. It's cardboard. That's a little bit of an issue here. So let's go ahead and cross that off the board. Fly-by-wire, however, I thought about this, which is basically flying by electronic wires. But in this case, we're doing a fly-by-wire wireless system because I have this radio control. We have wires that control the servos, and then we have a wireless connection to the back of the airplane. It's simple, as in I have a lot of RC experience, so this is pretty simple for me. It's fast because I've done so many RC airplanes. It's pretty easy to take a servo and connect some linkages to. And there's no entanglement hazard for me inside the cockpit because I'm sitting there with a tiny remote control to fly this stupid airplane. The cons are, though, it's electronic. Meaning, if someone had an RF jammer, they could technically make me locked out of my airplane while I'm flying it, which would be very bad. It's also made out of hobby parts, which are not designed for human flight. I think we are going to go with fly-by-wire wireless, because I think this is probably going to be the winning move. And also, there's something just so funny about sitting in the world's largest RC airplane, too. On top of it being made out of cardboard and flying in it. Because, you know, that's every kid's dream of, like, building a giant RC airplane that you can hop inside of and fly. Except you're still flying with a controller. Okay, speaking of RC control, I know you guys are probably freaking out about that a little bit, but I did plan this with some redundancy. I didn't really quite explain this in any of the past videos, which you should probably check out if you want to see the full series. But this is a basic summary of how it works. There are 2 RC receivers on the airplane, and there's 1 controller that my hands are attached to. However, receiver 1 is responsible for the motor controls and half of the elevator. That means if something really bad were to happen and receiver 1 were to explode, become disconnected, or just stop working for other reasons, I still have control of the other half of the elevator, and I have control of rudder because that's connected to receiver 2. And these are all completely isolated from each other. They do not share battery packs, they do not share voltage regulators. So there is some redundancy here that I've thought about. So I think this is probably the safest way I could probably make this whole system, other than giving every single servo its own radio, but that's getting a little ridiculous. But we are only flying this once. I'm not flying this ever again, so I don't care. It just needs to be solid enough to not make me unalive myself in the first flight. Every plane needs instruments, so therefore I have my old Pizza Hut dinner. So now we've finished all systems. Let's head to the field for the first test flight.
It's got some pull.
This thing is still cardboard, but it's probably 96% cardboard now, maybe 97. You pick up the wing a little higher.
It's way up past more I can reach it.
You can still see the plywood in the wings, but who cares? It's tight, right?
I can't really. Yeah, it's tight.
We've done the center of gravity check, and it all checks out pretty good.
Don't pull on that. You won't rip.
He's like Charles Lindbergh, how he has to stick out the side to fly, see the plane.
Alright, hand me the radio.
Alright, transmitter.
Alright, seems okay.
Alright, the plane sucks, and it's mainly because of the wheels. The wheels have a lot of rolling resistance in this grass, so I might have to tweak it a little bit. The plane's a little underpowered, and mainly it's these wheels. They're just so draggy and they can't really cut through this grass. So I saw this thing online where they tow old aerogliders into the sky to do some training, and basically we can do the same thing here. Except I'm not even worried about it because the sled is firmly attached to the car and I have this pin to release it. I can eject this whole assembly once I get in the air. So we're gonna use the car to give us a little bit of a boost, get me airborne, and then I can kick and release the sled and hopefully just fly away.
All right, start moving.
I'm gonna speed up. Keep going faster a little bit. All right, he's off. Oh, there go the prop.
Okay, we've done the test flight. We broke the props. I basically made the world's most expensive, elaborate lawn aerating machine because I broke the propellers in the mud. So we have to come back to this drawing board and fix some stuff. You know what I need to fix? I need to fix the plumbing in my shop. What the shit? Why is it all wet? Where did this water come from? Oh god, they're all wet.
This is not good.
When I came back into the shop, I put the wings down, and then it flooded. You know this foreshadowing here with the don't fly in the rain? Yeah, it turns out that it's actually bad to make jokes like that, because sometimes the water gets on things that's not supposed to be wet. Alright, so this is our problem. Like, the RO system puts water in here, and now the shrimp have swam up through the glass. They're right here. Come check out. Look at the shrimp. They're right there. They're on the top. Oh, this is horrible.
So when I said fill the water over this black plastic, I meant like the bottom of it.
I erased the whiteboard, and now it's time to repair these wings. The wings need to be repaired. They're still pretty wet. The one weakness of cardboard: water. If this stupid thing on its edge would have been stood up by like literally this, it would have been fine. We wouldn't be in the situation right now fixing this. We were supposed to fly tomorrow, because tomorrow it's going to be 60, like 10 miles. It's going to be perfect. It won't be a wing folding situation, which would be the worst possible thing. It'll just be loss of lift pretty severely and, you know, pretty fast dissension as this all comes apart. Okay, let's cut the trailing edge off. That's not too bad. It's just a little soggy, and the water only went so far into the airframe. Luckily enough, I have more cardboard left, so let's cut all this off, laser cut some new pieces, and replace the trailing edge. So we were at the field, and we learned a lot. Mainly my undercarriage sucks a lot. It sucks so bad that I need to build a better one. So we're going to get some of this chromoly steel, which is very lightweight, but also very thin-walled, and we're going to build this carriage. I'm sure I can build a nice chromoly landing gear assembly that doesn't really violate the cardboard rules and spirit of this project, because it's just for taking off. It has nothing to do with actually the airframe itself and keeping me aloft, so I don't think anyone cares if I cheat here just to get this thing airborne. With this angle set, it's kind of like a bicycle, and bicycles can honestly steer themselves if you're balanced well enough. So that should center when we're starting to run, and it shouldn't flip-flop like the other wheel. I also have this toe point here, which we're printing a latch out that's going to be servo release, so in case this doesn't work and we still can't get up to speed with just the wheels and this new power system, which is basically the same power system, just more batteries, we can also just tow it, and I can hook the tow line to the steering bar, so the tow vehicle will actually direct where I go. So as long as the tow vehicle stays pointed directly into the wind, I shall be fine. And then I can release the tow vehicle with the single flick of the radio control switch. Basically making this thing super easy to deal with, because I'm so used to flying with RC stuff in my hands that I can flick a little switch without freaking out or thinking too much about it. Like I did kicking that block out from the first time and really kind of screwed up my attempts at flying. It's more of like a pilot saturation overload, mainly because this pilot has some skill issues. Run to that.
So I'll probably cut out a little groove so this thing can steer a little bit. I'll also have to move some. Make sure landing gear is affixed firmly to airframe with airframe fix. When really the worst thing that happens if this fails is I just end up on the ground with broken propellers again. So it either works to let me take off or it fails and I just don't take off. Alright, how's it look?
Oh boy, this thing looks great. Okay, that's only like 15 pounds. It's like a fraction of the weight of the other one. So the undercarriage and release mechanism is now complete. The last thing I need to do is upgrade the power system, because I noticed a lot of you guys have commented about maybe fixing the drag with a cockpit windshield, maybe cover my wingtips a little bit. All very valid points if this plane were to fly really fast, but unfortunately the plane can't even really make 20 miles an hour. So I think the biggest thing we need to focus on is just a little bit more electrical power. So huge thanks to Buddy RC for hooking him up with some new batteries. They got these tattoo batteries if you guys are looking for anything RC or getting your own RC supplies. Check out Buddy RC. It's a great resource to grabbing stuff like batteries, motors, ESCs and all that, because they provided that for this project. And without them, we're not getting this extreme power upgrade. Basically just 2 more cells. So now we have these bigger batteries. We are actually ready to go to the field and try to really fly the cardboard airplane. Is this project illegal? It is actually not illegal, because this ultralight flies under something called Part 103 operations. It's basically an ultralight, and the rules and regs for that basically fit almost on a sheet of paper when it comes to your airframe vehicle design. Under 254 pounds, fly less than 55 knots, it has to have a stall speed of around 25 miles an hour. I don't know all the regs. I do know this plane does not violate them, though, because I've made sure that everything falls well under that because I've had trouble with the FAA in the past. So before you go and report me, if you see anything in this video, the FAA really doesn't seem to care about ultralights from all the research I've done. They don't even really care if you crash your own ultralight. They only care if you involve other people in your shenanigans or you break airspace regulations, which we will not be doing any of because I'm flying on a private field. I'm flying maybe 20 feet up in the air, so there's no chance of hitting a civilian airliner with my airplane. They only care about N-numbered stuff, which is registered with the FAA, and that basically means stuff that carries passengers, because the moment you involve someone in your shenanigans, that's when you can get in a lot of trouble. For me, I'm not really worried about that. So the cardboard airplane, it's legal. It's actually legal to do for now. We're at the field again. We've got the wings on the airplane. I made a little bit more adjustments. The plane has a little bit more of this dihedral because the plane has no ailerons, because I didn't want to put them on the wings because I wanted to save weight and be cheap. But this is what it looks like. From last time, it was a little more flat, and I noticed the plane did roll over a little bit and hit its left motor, so maybe adding a little more dihedral like my 4th airplane will correct this mistake. With all of this on the line, all of this effort, time, and energy put in this airplane, it's finally time to really see if we can fly this. We've done everything possible to make sure this can go together. The upgraded power system, the new wheels that hopefully don't roll through peanut butter like the skinny, crappy tires, and a super upgraded release hitch made out of plastic. Oh, that's so much easier to push than last time. Yeah, so we have a lot less rolling resistance, because when I got out and pushed, it sucked last time. It still sucks, don't get me wrong, but it rolls easier. Am I really gonna fly in this thing? It's too late to back out now. It is time to fly. And let me climb into my cardboard box of doom.
Baby, you got a booger coming out.
With everything set, all the cameras are rolling, let's make history.
All right, I'm gonna try it.
Adding throttle. It's rolling, it's good. I can feel the vibrations, and it's off. Okay, well, it's back on the ground. I may have pulled the power out a little bit too much.
It definitely flew.
So that run was pretty good. We've definitely got it further than we've got it before. However, I made this release hook and I have the tow vehicle. I think we're gonna tow it and launch it again because I want to get some real height and really get this thing into the sky. Take two. Let's really make history this time.
Yeah, I'm good. Let's go.
This is really going to be it. It's either this or the plane gets scrapped and never gets touched again. I have to fly this plane. Otherwise, I have to delete my channel because I would be a fraudster if I were to put this title of flying an airplane and we don't fly this cardboard airplane. We're flying, we're actually in the air. I am flying in cardboard. I'm gonna go lower. I don't want to fly this high because I did the testing. I know the wings are gonna fold, but I want to go lower, so let's go lower because I do not want to break the wings on this. Let's come down a little bit. All right, we're skimming, we're flying. Wait a second, I actually didn't think this through. Where are we going? Okay, let's pause for a second. I knew if this plane were to fly, this is my only chance to fly a cardboard airplane, and I'm not going to be doing this again. So I'm gonna milk this flight for as much as I can get it. It's flying really good, it feels alright, the yaw control is really responsive, and elevator is actually really sensitive, but we're gonna skim along the runway, and I'm gonna turn a little bit to the right. This runway is basically shaped like this. I'm doing my right-hand turn, because there's corn over here, there's corn over here, this is all a cornfield too. That's all a really big cornfield, so I'm going to turn around here and stay low to the ground. It's banking really, really good to the right. Okay, it's now time to turn a little bit to the left. We've got to make this thing because there's trees over to my right, there's trees in front of me, there's trees over here, there's trees everywhere, and I don't want to run into them. So we're making this big circle. Oh Jesus, I think I'm actually running out of options here. Oh wait, there's this really small spot that you can see right here that I think I can fly through. I'm gonna keep climbing. I'm gonna climb and I'm gonna turn a little bit to the right. And I have made the mistake of my life. I parked it in the trees. Well, it turns out that this elaborate plan here threw it out the window because it didn't really quite work out that way.
Oh, I screwed up. All good.
It felt so much better than I thought it was going to be, so I was like, rather than flying down the runway, let's try to do one full circuit. So I initialized my turn. I should have initialized more of a turn because this is an aileron-less airplane. You steer just a ruddered elevator. Okay, I know I need to lead my turn to make a big circle. Let's go to the right. this feels like it moves pretty fast to the right, so I should be able to turn around all right. So I went this far out, started to turn, I was like, oh wait, no, I'm already halfway across this field, and I know these trees are over here, so I was like, I don't want to hit those trees. So I was like, I made an executive decision at that point to turn towards the big empty cornfield over that way, but I have to pass a 10-foot tall little berm of trees. Started turning forward, ran out of airspeed and options, so down it went right into the brim of the trees. Because I saw the hole and I went for it. This is maybe a little bit off script, but I knew everything involved with the plane being as slow as it was and my surroundings, nothing really bad was going to happen, because this plane would only really hurt me badly if I were to fall out of it or the wings were to fall. And with everything I knew, really the only accident I have to worry about is how I come to stop from 20 miles an hour. Overall, this spread of time from this 20 mile an hour to the sudden stop I had was generally enough to completely walk away with no injuries. Moral of the story, find a bigger open space. Oh, also, probably don't build an airplane out of cardboard because it's kind of a stupid idea. But, can you fly in a cardboard airplane? Absolutely. Is it a good idea? Absolutely not. Still a success, no broken bones, and we flew the cardboard airplane. Now, about that airplane, what does it look like?
Hey, what's the plan?
Oh my god, that was crazy. The front fell off. What's wrong with it? Well, the front fell off. It's still solid. Should I fly it again? Probably not. I found it. Oh, check it out. I got some new drip. This is my logo in cardboard. And this is the back of the cardboard airplane. If you guys want some new shirts, it's been a while since I released anything, check it out in the link down below. Speaking of other things for sale, check this out. So this is the actual instrument I use in the airplane. It's still in the pizza box. However, I made a really cool miniature version because, well, I had a few of these Adrenos laying around. It's basically the exact same code uploaded in the actual flying instrument into this. I wouldn't actually use it for flying because it's not exactly accurate, but it does function the way, basically, an attitude indicator functions as. So this is a handmade item. I was making 30 to sell. I broke 2 of the screens. I just broke this one putting it together. They're so fragile at the corner. It's like this thin glass at the end of the OLED panel. You push it and it breaks. So watch when we turn this one on, because it's broken. Let's break the other side, see what happens. Oh, that doesn't look healthy. So we got 28 of these instruments for sale. So basically it's a little self-contained doodad that you can have for a desk toy. So if you want a cool gift to give someone, I don't know, this would be a cool gift. I think this thing looks sweet. And I've only made 28 of these and signed them on the back. So if you guys want to check it out, there's a link down below. They're basically the exact same code I've got running in this one. I'm posting the code for free because honestly I'm going to charge kind of a lot for these because I only made 28 and I'm kind of going to see what happens here. Plus I need the funds for new ultralight. So if you want to support me, check it out. And if you don't, well, that's cool. The code's for free. You can make it yourself.